let's say f of xy is x cubed minus 12xy plus 8y cubed. Question is, find all critical numbers and determine the type using second partial derivatives. And by type, I mean, is it a relative maximum, is it a relative minimum, or is it a saddle point? It's one of those three. That's what you have to do. You have to categorize which one it is. All right, so let's try to solve this. First, what's a critical number again? It's a point where
the derivative
is all the derivatives are zero. All the partial derivatives are zero, right? So to find critical points, you need gradient of f to be 0. And because this is a vector, this is really 0 as a vector, meaning all the components must be 0. And what's the gradient here? If you differentiate x cubed by x, you get 3x squared. And differentiating this by x, you get minus 12y. Differentiating the last one by x, you get 0. So that's what you get. And then if you differentiate by y, that's 0. This differentiate by y is negative 12x. And the last one differentiate by y, you get plus 24y squared. And that has to equal to 0, meaning that I need 3x squared minus 12y equals to 0, and negative 12x plus 24y squared equal to 0. So you have a system. Now, I know that you don't have a lot of experience in solving systems, especially if it's not a linear one. But if it's not a linear equation, the solution is still the same. What do? You solve for one variable, and you plug it into the next. That's all. Okay? So let's do that. Let's solve this for y, because it's easier to solve for y. What do you get? You get 3x squared equals to 12y. Dividing by 12, you get y equals to 1/4 x squared. That's what you get. Good? And then you plug that into the next. Let's see what we get again. Negative 12x, that's not changed, but 24. And instead of y is replaced by 1/4 x squared. And you have to square it. Equal to 0. Okay, now let's see what it becomes. Negative 12x. 4 squared is 16, so you have 24 over 16, x to the 4th equal to 0. I guess that they're both divisible by 8, so it's 3 over 2. 24 is 8 times 3, and 16 is 8 times 2. And then if I multiply by 2, I get negative 24x plus 3x to the 4th equal to 0. So that's what we have so far. Now, let's try to solve this. How does it get solved? You get 3x. You can factor it by 3x. Everything is divided by 3x. And this one is negative 8. This one is x cubed equal to 0. Right? That's what you get if you factor the 3x out. And then for this product to equal to 0, either 3x is equal to 0 or negative 8 plus x squared is equal to x cubed is equal to 0. This one simply means that x is equal to 0. And this one means x cubed is equal to 8, which means x is 2. But that's not all. For each case, we have to go back and figure out what y is. So when x is 0, what do you get for y? 0, right? Y is 0. For x equal to 2, what do you get for y? 2 squared is 4. 4 times 1/4 is 1. So you get y equal to 1. Okay, therefore, What are the critical points? 0, 0, and 2, 1, x, y. So those are the two critical points. And for each of these critical points, you have to figure out whether it's a relative max or relative min by using the second partial, by using the Hessian. So now let's come up with the Hessian. What's the Hessian of f? Well, we already have the first derivatives. This is f differentiated by x. Maybe I should write it through. This is f differentiated by x, and that's f differentiated by y. And Hessian means you differentiate twice by x. So instead of differentiating this twice by x, well, what should we do to this one? You just differentiate this by x. This by x, then that's the first element, right? So fxx, remember this is the Hessian, fxx, fxy, fyx, fyy. And that's the first thing differentiated by x would be 6x. And then to get fxy, you would differentiate this by y, right? What do you get then? This differentiated by y is 0, negative 12. And then we can always take this shortcut that fxy is always same as fyx. Right? Well, the condition is that the second derivative should be continuous, but we don't care. Usually it's true, and we'll never run into these strange cases. So it's same. So negative 12 here means negative 12 is also here. And then fyy. That means I have to differentiate this by y, right? If I differentiate this by y, what do you get? 48y. Therefore, this is what you get. 6 times 48 is 288xy, right? And 12 times 12 is 144 minus 144. So that's your Hessian. And now let's try to figure out Hessian for each case. What is h of f evaluated at 0, 0? That means I'm plugging in 0 for each one of them, right? So you get negative 144. So this is negative, which means you have? It's a saddle, okay? Because this being negative means there's a change from a frowning face to a smiling face at some point, okay? Yeah. Or vice versa. So that's what it means. This means that 0, 0 is a saddle. Whereas, let's think about h of f of 2, 1. What's that? That means I'm plugging in 2 here into x and 1 into y. Isn't that right? What's twice of 288? That's 576, right? Minus 144, which is, I don't really care about the exact value, right?
432.
Huh? What?
432.
432, okay. And that's positive, right? You just have to know whether it's positive or negative. So that's positive. What does that tell us? Nothing yet. We don't know if it's a relative max or relative min. So in addition to this, what do we need? fxx has to be also evaluated at 2, 1. Well, what is fxx? It's 6x, right? So if you evaluate with x equals to 2 and y equals to 1, what do you get? 12, which is positive. So from these two, we can conclude that 2, 1 is a relative min. Okay, that's how you use the second derivative test. Make sense? Do you have any questions?